ndole kabunga nyoma bari nyambukiro nyimanya na kafindi nyinambe korosor laga nyinambe korosor laga
ngale limbeta de be nyambodo dilanna
nyara ni ko rim fennat nyara nata
koto bari famo kada
ngata bungono tammi bungono nyara ngando ko fele ko ke baru ngana ni pelo landi jak
iyo awe better la
bungono bismillah bisu diara
ye fungo tanka sina dolu tanka koro ta koro ta.
Hello viewers and listeners, we welcome you again to another mathematics lesson of the upper basic component, and today we are still on inequalities, and today we will be continuing with our two-step and multi-step inequalities. We did one step in addition and subtraction. We did two steps as well, or one step as well, that involves multiplication and division, but today we will be doing two-step and multi-step inequalities. But before we do this, we will get back to our homeworks we have the other time. We have two homeworks. One is solve and graph negative 5y is greater than or is less than or equal to negative 25. Negative 5y is less than or equal to negative 25. We have to solve this and graph it on the number line as well. Our first homework was negative 5y is less than or equal to negative 25. Negative 5y is less than or equal to negative 25. So if you have to solve this, first all we need to do is to undo the operation. We have negative 5y means negative 5 times y. In doing so, we know that because we were multiplying, so the opposite of the operation there is division. So we will divide both sides by the coefficient of the y here, which is negative 5, and divide here also by negative 5. Negative 5 cancels negative 5, so we are left with y is less than or equal to, because we are multiplying by a negative number, sorry, the sign will change to its opposite. Because we are multiplying by a negative number, our sign will change to its opposite. So therefore, in order to have a less than or equal to, we will have a greater than or equal to. Negative cancels negative. So this will tell you that our answer will change to a positive number. 5 goes into 25 5 times. So our inequality here is 5 is greater than or equal to, sorry, y is greater than or equal to 5. And we are asked to put this in a graph as well. After solving, we need to represent this information we have here in a graph. As we talked about this earlier on, it is so important to show our zero. In fact, it's one of the most important digits that you will use in your number line. First, put your zero. Where the zero is so important, and because we have positive 5 here, the numbers all to the left hand side of 0 are all positive numbers, starting here positive 1, positive 2, positive 3, 4, and 5. So as you can see, according to the graph here, our y is greater than or equal to 5. 5 is inclusive, because it's greater than or equal to 5, it can be equal to 5, and it can be greater than 5 as well, which is why our arrow is pointing into the direction where all the numbers that you have there are all greater than 5. So this graph represents the information here, y is greater than or equal to 5. This solves our first question. We move on to our second assignment. Solve and graph n over negative 2 is greater than 3. N divided by negative 2 is greater than 3. N over negative 2 is greater than 3. This is our second assignment. And because we were dividing here, the operation here is a division. We are dividing the n by -2. So in order to undo that, the operation there, which is division, and also to isolate our variable n, we need to multiply both sides by the denominator. And therefore, the denominator here we have is a 2, -2. So we multiply here by -2 and multiply this side also by -2. -2 cancels out -2 automatically. Because we were dividing by it, we are multiplying by a negative now, we'll have n is greater than 3 times 2 is what? 3 times 2 is -6. We have n is greater than -6. N is greater than -6. So this is the information that we got after solving an inequality. So now we need to represent this answer into a graph on a number line. We draw our line and we remind each other that the most important digit here is the 0. So the 0 must be written, all right? And then the given number here, which is -6, also should be captured here. These are the two most important figures we have. The rest, if you want, you can write them, but they are of no use as long as the graph is concerned. So now, this is greater than, so which tells us that our -6 is not inclusive. We have an open circle. We are not going to close our circle because -6 here is not inclusive. Okay? The other thing that we discussed the last time was, look at the direction at which the sign is pointing. Know that your arrow should also go onto that direction. Okay? Therefore, our arrow goes this way, indicating that all the numbers from -5 are all greater than -6. Remember, in integers, the bigger the number, the lower its value. That tells us that even -5, the closest to -6, is bigger than -6. -1 is also bigger than -6. Okay? So this solves our question. We got our answer here after solving our inequality, and then we have graphed it on the number line here. So this is the answer to both our homeworks we have the last time. Now our lesson proper today is solving two-step and multi-step inequalities. Inequalities that will involve more than one step to solve, okay? 2 steps or even more than 2 steps in the multi-steps. Now our objectives here is, by the time we are done with this lesson or the topic, we should be able to solve inequalities that contain more than one operation. That contain more than one operation, okay? And we should be able to solve inequalities with variables on both sides of the inequalities. Where we have variables on the left-hand side, it is very, very possible to have the variable on the right-hand side as well. So we will be seeing all those things, and then we'll be discussing and going through it. Now, we will solve some more complicated equations and inequalities. Okay, equations comes in here just to tell you that equations and inequalities are very, very similar. They are only different is the equal sign in the equation and the inequality sign in the inequalities. They all consist of terms and variables and operations. Okay? So we have something to solve here. You can solve two-step inequalities in the same way you solve an equation. The way you solve two-step inequalities is the same way you solve two-step inequalities. The first example we have here is 3x minus 10 is less than or equal to 14. It is solved in the same way as 3x minus 10 equals to 14. Look at these two inequalities, the equation and the inequalities. You can see the only difference here is the equal sign and the inequality sign. The first one on top is an inequality, and the second one is an equation because that consists of an equal sign. Now to solve this, all we need to do is we undo the operation there for us to isolate our variable, okay? So in doing so, we have to add 10 onto both sides. Add 10 onto both sides. If we add 10 onto both sides, that will give us 3x is greater than or equal to 24. And we'll be doing this here as an example. We have 3x minus 10 equals to, or is greater than, less than or equal to 14. We have to solve this inequality. So therefore, we will add 10 onto both sides. By adding 10 onto both sides, we will isolate our variable, okay? Not to isolate our variable totally, but we will have 3x here. Negative 10 plus 10 is 0. We bring down our 3x. Greater than or equal to 14 plus 10 is 24. So now we want to isolate our variable. We know that 3x is 3 times x. So because it's a multiplication, the opposite of a multiplication is a division. So therefore we divide here by 3 for us to isolate our variable. And for the fact that we have divided here by 3, we must divide the other side also by 3. 3 cancels 3 automatically. 3 goes into 24 is 8 times. So therefore, we have x is less than or equal to 8. So our answer here is x is less than or equal to 8. Okay? Now this is the solution to the inequality we have. Okay? Now a contrast of this is given in an equational format where we have 3x minus 10 equals to 14. But that one is an equation. Our purpose of that, bringing that one, comparing it with this, is just to know that an equality and an equation has only one difference, that is this sign. The equational sign and the inequality sign. That is their only difference. Now, this is a hint here that we must remember always throughout. If you multiply or divide by a negative number, reverse the direction of the inequality symbol. We did this before, and we will do it again. If you multiply or divide by a negative number, whenever you multiply or you divide by a negative number, the reverse of the inequality sign will come. If it was a greater than sign, it will be a less than now. And if it was a less than, it will be a greater than now. Okay? So the question we have there is negative 3x is greater than, sorry, is less than or equal to 24, as we had before. Now, this is a negative number. So in order to isolate our variable x and to undo the operation of negative 3 times x, we have to divide both sides by negative 3. In dividing both sides by negative 3, we'll achieve two things. One, to isolate our variable. Two, to undo the multiplicational operation here. We all know that the opposite of multiplication is division. So whenever you have an operation that is a multiplication, you need to divide to have to isolate our variable. So we divide here by negative 3, and therefore we divide this side also by negative 3. Okay? Negative 3 cancels negative 3. We have x. But let us remember that we have divided with a negative number. So this will change our inequality sign to its opposite. It will have a reverse of our multiplicational sign, our inequality sign. So 3 goes into 24 8 times. And remember, we are dividing with a negative number, so therefore our answer should be negative. So the solution to our inequality here is x is greater than or equal to negative 8. X is greater than or equal to negative 8. We have number 1 here. Solve this two-step equation. We have an equation here, and we'll be solving this equation. Just to highlight the relationship between an equation and an equality. So now, we'll have to solve this. The equation here is 5 minus 5x equals 0. 5 minus 5x equals to 0. We want to undo this 5. Because, why do we undo the 5? Because we want our variable to be alone. In doing so, we subtract 5 from both sides. And subtracting 5 from both sides, 5 cancels 5 here automatically, as we have here. So we bring down our negative 5x, which is equal to negative 5 minus 0 is negative 5. 0 doesn't change anything here. So all we do is we divide both sides by negative 5, as we have been doing, negative 5. Negative 5 cancels negative 5. Negative 5 goes into negative 5. We have 1. So x is equal to 1. Our value of x here is equal to 1. But this is not an equation, an inequality, but it is an equation. Now we will be solving an inequality. Solve this two-step inequality. The steps we took here are the same steps we are going to take, what we're coming to do here. Our question at hand is 26 is less than or equal to 3n plus 1. 26 is less than or equal to 3n plus 1. We'll use the additive inverse, the inverse of the negative, positive 1 here. Subtract 1 from both sides of the inequality. 1 minus 1 is 0. 26 minus 1 is 25 is less than or equal to 3n. 25 is less than or equal to 3n. All we need to do here is divide both sides by 3. 3 cancels 3, obviously. 3 goes into 25. We know that it's 8 times. Remainder 1 over 3. So it's 8 whole number, 1 over 3 is less than or equal to n. That is the solution to our inequality there that we have. Try this. Now we will try this by solving and plotting. We'll solve and graph our answer on our number line. Okay? The first one we have is 6 minus x is equal to, is greater than 3. 6 minus x is greater than 3. The question says, let us solve this. Then after solving, we also plot it on our number line now. So in trying to solve this here, all we need to do is we want the x to be alone because it is a variable. Okay? So in doing so, we are going to subtract 6 from here because this is a positive 6, and we therefore subtract 6 from the other side. Remember, as the rule of equations, whatever you do on the left, you must do on the right as well. So 6 minus 6 is 0, obviously. So here we have negative x is greater than 3 minus 6 is negative 3. 3 minus 6 is negative 3. So all we need to do is here, remember negative x means negative 1x. The one shall never be visible, but it is there. Okay? So in trying to undo the negative sign here, we must divide both sides by negative 1. So in dividing both sides by negative 1, first, the direction of our sign will change to its opposite. Okay? And negative cancels negative here, so we have only x. And then this negative will cancel this negative, so our answer will be positive 3. So we have x is less than 3. X is less than 3. That's the solution. Now we have to represent this on a graph. Okay? As we said before, our 0 is so important. We have 1, 2, 3, 4 if you like, negative 1, negative 2, negative 3, and negative 4. The most important numbers here is the 0 and the 3. Okay? So now, where is the tree? Is the tree inclusive? It is telling me x is less than 3, so therefore the tree is not inclusive. The tree will be an open circle. And to which direction it is heading to? It is going to point at a direction where all the digits there are less than 3. So therefore, it is coming in the same direction as to where the sign is pointing to. So that's a small technique that you must keep in mind, that this sign here points this way, and therefore the head of the arrow also is going that way. So this is a simple technique that you shall always put in mind so that you will not confuse these two signs, because it is sometimes confusing to students. All right? So our inequality will be, our open circle will be at 3, and to any direction, and to the right hand side direction of the tree, the left hand side, sorry, indicating that all the numbers there are all less than 3, are all less than 3. As you can see, 2, 1, 0, negative 1, negative 2, negative 3 are all less than 0. And also to remind you, the arrow here doesn't have a specific length. Okay? It could be very short and it could be very, very long. Okay? What is important is show the direction that it is going. No matter how short or long it is, it all indicates that your inequality is pointing to the direction you put the arrow. So we move on to the other question here. The question number 2, negative 4c plus 16 is less than 0. Negative 4c plus 16 is less than 0. The same way as we did before, we would definitely like our variable with the term to be on one side and to be alone there. So therefore, we subtract 16 from both sides. We bring down our negative 4c. 16 minus 16 is 0. Less than 0 minus 16 is negative 16. So all we do here, in order to isolate our variable c, we divide both sides by negative 4. Negative cancels negative, or say negative 4 cancels negative 4. Okay, because we are dividing by a negative number, our sign should change to its opposite. Okay, so negative cancels negative, 4 goes into 16 is 4 times. So therefore we have c is greater than 4. Our answer is c is greater than 4. Again, let us represent this on our number line here. As I said, let's put our 0, and the digit here we are given here is 4. Okay, 4 is not included, so we have an open circle at 4. Our circle should be open. Okay, and then it's referring to all the digits that are greater than 4. As you can see, from 4 you go to 5, so all numbers this way are all greater than 4. So this is the correct graph that represents the answer to our inequality here. We can still move on here. We have solve and graph each inequality. 6 minus x is greater than 3. That's number 1. Now we'll move on to number 3. Solve and graph each inequality. Number 3 is negative 3y minus 21 is less than 0. We'll solve and graph both number 3 and 4. Okay? Again, all we need to do is the additive inverse of 21 tells us that we should add 21 onto both sides so that we can eliminate 21 and 21. So we have negative 3y is less than 21. Negative 3y is less than 21. So all we need to do here is what? We divide both sides by negative 3. Negative 3 cancels negative 3. We have y is greater than, because we divided by a negative sign, so our sign will change, inequality sign will change to its opposite, and therefore we have negative 7 as our answer. 3 goes into 21 is 7 times. So we have y is greater than negative 7. We have our number line, we put our 0, and we locate our negative 7. Okay? So negative 7 is not inclusive because it's greater than. Okay? And then it points to this direction, showing that all the digits on this side from negative 6 onwards are all greater than negative 7. So y is therefore greater than negative 7. So we move on to question number 4, which is 22 is greater than negative 5x plus 18x minus 4. 22 is less than negative 5x plus 18x minus 4. Here we have variables on only one side, although it is a longer inequality. So we need to simplify that aspect first. We shall say 22 is less than negative 5x plus 18x is 13x minus 4. Okay, the integer there, you can never add a positive and a negative number, so all you do is you take a smaller digit from the bigger digit and maintain the sign of the bigger digit. Okay, so therefore all we have to do here is we add 4 onto both sides. This will help us to eliminate 4 here, because 4 minus negative 4 plus 4 is 0. So 22 plus 4 is 26 is greater than 13, is less than 13x. Okay, we divide both sides by 13 to isolate our variable x. 13 cancels 13, and 13 goes into 26 is 2 times. So therefore we have 2 is less than x. We draw our graph here. Our answer is 2 is less than x. We draw our graph, locate our 0, knowing that our answer is a positive number, so therefore it should be here. Okay, and then now, is the 2 inclusive because it's a grade less than? No, it is not inclusive, so therefore we should have an open circle. So after having an open circle, it points to the same direction as the sign, the inequality sign we have at hand. Okay, so therefore 2 is greater than x. 2 is less than x, meaning all the digits here are all less than x. Oh, sorry. 1 second. We must interpret this in this form also. Okay. 2 is greater than x is the same as x is less than 2. Having 2 is greater than x is the same as x is less than 2. So therefore, we can use that to represent it on our number line, where we will have our 0 here. The 0 is located, and then where is our 2? Let's have our 2 somewhere here. The 2 is not inclusive, so therefore it should be an open circle. And to which direction it is going? It is pointing to a direction where all the digits in this direction are all more than 2, which says x is greater than 2. All the digits you have after 2 here, 3, 4, 5, they can all be the possible answers to this inequality, because they are all greater than 2. Again, we have another inequality to solve. We have solve 18 is less than or equal to 4 into x plus 2, and also graph it. Okay, 18 is less than or equal to 4 into x plus 2. Okay, then we graph it. First, all we need to do is we expand our bracket. Expand our bracket in the same way that we were expanding our bracket in equations. In doing so, we have 18 is greater than, less than or equal to 4 times x is 4x, plus 4 times 2 is what? 8. Okay? So we go further. by subtracting 8 from both sides. 8 cancels out 8. So 18 minus 8 is 10 is less than or equal to 4x. So all you do here is divide both sides by 4. 4 cancels 4. You say 4 goes into 10 is 2 times. We have a remainder of 2. 2, if we add 0, it becomes a 20. We have a point, 2 goes into 2, 4 goes into 25 times. So in other words, we have 2.5 is less than or equal to x. 2.5 is the same as 2 whole number 1 over 2. Okay, it's 2.5. Okay, 2.5, 2.5 is greater than or equal to x. It's the same as x is less than or equal to 2.5. So this information, we need to plot this on a number line. Okay, we have our number line somewhere here, and we graph it here. Okay, we have x is greater than or equal to 2.5. X is greater than or equal to, let's indicate 1 and 2. 1, 2, and 3 maybe. And know that 2.5 is exactly between 2 and 3 because it's 2.5. Okay? So we have our closed circle there. Now our 2.5 is inclusive, so we have to close the circle and point it to the direction where all the digits there are all more than 2.5. X is greater than or equal to 2.5 is represented on the number line as it is here. Okay, so this comes to the end of our class, and I have 2 assignments for you, which is this: solve 16 minus x is greater than 7x and graph it. Solve 16 minus x is greater than 7x, you solve and graph. And the other one is 8 is less than 5x plus 3. Obviously, you will solve and graph this one as well. I thank you so much for your kind attention, and stay safe at home.